Hello, everybody, and welcome to our second webinar on topics and data sharing. Today, we have our speaker, Nicole Contaxis, who will speak about understanding and leveraging data discovery and sharing infrastructure. One moment, and we will get started as soon as the participant list slows down a bit. And until then, I wanted to let you know to please ask questions in the Q&A section rather than in the chat. That way we can track questions and make sure we answer your questions at the conclusion of the presentation. All right, it looks like our number is holding pretty steady. So Nicole, is it all right if we get started with you?
Yeah, let's do it.
Great. Okay, I just want to introduce Nicole Contaxis. She's the head of data sharing and metadata management and is a member of the data services team at the NYU Health Sciences Library. Nicole leads the NYU Data Catalog, a data discovery tool, and she is one of the content experts at the uh, Network of the National Library of Medicine's National Center for Data Services. I know where I work. Her research interests include data infrastructure, data ethics, and community engagement. So without further ado, I'll hand it over to Nicole.
Beautiful. Thanks, Peace. So let's get started. We have a fair bit to talk about today. I will say the initial title for this talk included how to leverage it for your benefit. And I've removed that because I think it's not just for your benefit, but rather for everyone's benefit. And I will expand on that a little bit as we go. So the learning objectives for this webinar are that by the end of this webinar, I am hoping that you will be able to state where to learn about available data discovery and sharing infrastructure, describe how these pieces of technology interact when a user searches for data, and then try to apply some of this knowledge when sharing your own data or maybe assisting researchers with sharing their data. And to hit those objectives, we're going to start off with some introductions and definitions. Some of these definitions may be review for many people on the call, but I just want to make sure we're all on the same page. And then I'm going to talk about why we need to center infrastructure in this talk. This talk is really going to be about infrastructure as a concept and the pieces of infrastructure that we have and try to use when we share and find data. So this will be less about, how to use that infrastructure, but really talking about that infrastructure as a concept. Then we're going to talk about how it works, how infrastructure works, and how it works together. So how pieces of infrastructure can interact. And I'm going to go through two general observations about this. The first is how efficiency plays a role in the ways we use and build infrastructure. And then this concept I call veiling and unveiling, which is a very sort of poetic way to talk about the way infrastructure makes some things more visible and some things less visible. And these observations are meant to help us make choices about the infrastructure we choose to use in our data sharing strategies. And then finally, I'm going to talk about what this means for you as maybe a researcher, maybe as a librarian or person who supports researchers, and also perhaps as a person who helps build or maintain infrastructure, as that type of person may be on this call. So let's get started with introductions and definitions. Peace gave a pretty nice introduction to myself, but I always like an excuse to share this photo. I do, as you said, lead the data sharing initiatives at the NYU Health Sciences Library. Largely, what that means is that I provide expertise to departments and divisions administrators and researchers on strategies for them to share their data and to manage their data. This type of work has really picked up since the 2023 NIH data management and sharing policy. And so there's a lot of work to be done in helping people develop, workflows and strategies for sharing data. And we've already talked about my academic interests, so we'll keep going. Now, most of my work at NYU focuses on leading the NYU data catalog. I'm going to use this as an example throughout a lot of the presentation, but just so you know, the NYU data catalog is it's a piece of infrastructure that helps researchers find data no matter where it's stored. So it can be stored on any repository, it could be stored on private servers if, say, that data has PHI or is otherwise protected. And this just uh, provides metadata for users so that they can find that data. So I want to start with a quick exercise. Now, as P said, please ask your questions in the Q&A section, but in the chat, if you could give me a thumbs up on Zoom if you've thought about the sidewalk in front of your office at some point in the last month. I'm sort of betraying my New York City bias here. So I can also say, have you thought about the parking lot uh, at your office? You just throw a thumbs up in the chat if you have. All right. Oh, I've got some thumbs up reactions. I've got a thumbs up from somebody wrote thumbs up into the chat. Um, okay, great. This is helpful. So the point of this exercise, excuse me while I continue to fumble with Zoom, um, is that a lot of times we don't think about infrastructure unless it's broken or if it was not built for us. So I don't think about the sidewalk in front of my office until the lip of the sidewalk goes up too high. Maybe it's icy. It's something that I'm going to slip on. It's no longer working for me. I'm sure if I had mobility issues, I would probably think about that sidewalk a lot more often because it's not necessarily built with my needs in mind. And the point here is that we don't think about infrastructure a lot, usually unless it's broken. So I'm going to try to surface a bit more of the infrastructure that we use throughout this talk, even when it's working quite nicely. Now, again, I'm going to betray my New York City bias. Part of the reason why I think it's important to talk about infrastructure, even when it's working, is how much it can impact our lives. So, if you've read The Power Broker, if you know who Robert Moses is, he built a lot of the infrastructure in New York City, and it's infrastructure that still impacts people's day-to-day lives. Talking very concretely, there are asthma rates that are higher in certain neighborhoods than in other neighborhoods because of where we decided to put highways through. So when we're building infrastructure or thinking about making changes to infrastructure, it's really important that we take a long time to think about it because infrastructure is expensive to build, it's difficult to build, and really does have a long-lasting impact on the actions we take in our lives. So now we're going to get into those definitions. First, because I'll be saying infrastructure so much in this talk, I want to start with the definition of infrastructure. And infrastructure is the physical and organizational structures that are needed for basic societal and enterprise operations. I just want to highlight here that when we talk about organizational structures, that might mean things like established workflows. It doesn't always mean, the roads we drive on. It may also mean the laws that dictate how we use those roads. Now, data infrastructure can be defined as the bureaucratic, technical, and social mechanisms that assist in data storage, management, sharing, and archiving. So it's all of these things that helps us interact with data, find data, store data. So it could be servers, but it could also be things like laws we have that dictate how we interact with our data. So here are some examples of pieces of data infrastructure. There are data repositories. These are pieces of technology that store data long term and ensure that it is available to people who have the rights to access it, if that's the public or somebody who goes perhaps through an application system. And these you can find out more through Re3 Data. There's also the NIH supported subject specific repositories. There are also data catalogs that I'll be talking a lot about today. These might not store data, but rather point to places where that data lives. So here there's the NLM dataset catalog, which is currently in beta. It's a new piece of technology and maybe worth checking out. There's also Google Dataset Search, which I will talk a little bit about later today. Persistent identifiers is another example of data infrastructure. So I've thrown some examples here. Maybe many people on the call probably know about DOIs. There's also ORCIDs, which are persistent identifiers for individual people. And there's also the Research Organization Registry, which are persistent identifiers for organizations. And these are, ways for us to differentiate between things that may be named very similarly so that we know which John Smith is the John Smith we're talking about. And then finally, another example of data infrastructure are things like data citation practices. Again, this might just be how we agree on how to accomplish some actions can act as infrastructure. And here, an example of a data citation project is Make Data Count. So I want to give some more detailed definitions of some other types of infrastructure, just to make sure we're all on the same page. Um, Standards get talked about a lot, but I want to make sure we all know what that means. Generally speaking, a standard is a community agreed upon way to collect, organize, or document data. Um, Standards help us ensure that data can be interoperable, so it can help us combine data sets. It can help us exchange metadata across many different systems. It can help us better aggregate data across many studies. And if you're interested in standards, you can go to fairsharing.org to learn more about possible standards in your field or for metadata related to your field. Related, there's metadata schemas and there's also metadata standards. I'll talk about this a little bit later on today. A metadata schema is a formalized collection of required and optional metadata elements. This can help people standardize how they describe information resources. For the librarians on the call, you've probably used a lot of different metadata schemas, whether if you were cataloging a book or cataloging a data set. And there's also metadata standards. Metadata standards are agreed upon ways to allow for consistent measurement, quantification, and exchange of an object, process, or unit of information. In plain language, basically, it's a way that we've all agreed to describe certain objects. This allows us to exchange pieces of metadata more easily and across different platforms. Importantly, some metadata schemas are metadata standards, but not all of them. There are also controlled vocabularies and ontologies. Again, for the librarians on the call, this will be review, but a controlled vocabulary is an organized arrangement of terms used to index content. So this is, if you have a pull down menu, this is the things that populate that pull down menu. Now, an ontology is a controlled vocabulary that also captures the relationship between terms. So it might be able to capture a parent and child relationship, saying that this term is the larger term that encompasses this more specific term. Some metadata standards will require use of a specific controlled vocabulary or ontology as a part of their overall standard. Now, the reason I'm going into this detail about metadata is that it's important to know that metadata can both be human readable and machine readable. When it's human readable, that means it's something that a human can read and easily understand and parse. This might include something like a natural language description of a data set. But machine readable is metadata that is structured in such a way that it can be easily used in a computational way. This machine readable metadata relies on persistent identifiers for disambiguation. It also relies on ontologies and standards in order to ensure that information is being exchanged in a way that maintains its semantic meaning. Now, a lot of metadata can be both machine and human readable, meaning that there are aspects of the metadata that is written in plain language. Then there are other aspects that are structured in a way so that it is easy for a computer to use it. An example here is the MESH, medical subject headings from the National Library of Medicine. You can see here, this is their sort of the more human readable side, right? We've got scope notes that talk about the definition of this term. But if we look at the tree view of it, we start to see a little bit of the machine readable side of things. So we see these identifiers. I'll just point this out with my mouse. So this helps for disambiguation. And if you notice these identifiers, you can see how these identifiers correspond to relationships across terms. So biological factors is D23, biomarkers D23.101. And so we can start to get an idea of how somebody might, if they were so inclined, use these identifiers to help investigate, what information is being included in a bibliographic resource, excuse me. So let's move past all of these definitions. If you have a question on any of the definitions I just ran through, please feel free again to throw it into the question and answer box, and I will clarify anything that needs clarification. But now I want to talk about why I'm going to center infrastructure in this talk. Um, the most important point that I would like you to take from this webinar is that data infrastructure has ethical implications and practical implications outside of the action it enables. To demonstrate what I mean, I'm going to give an example. This is an example is that a researcher wants to share their data related to a publication, and they have a couple of options about how to do that. Let's talk about our first option. So here they are, they've got their journal article, it's going to go on this publisher's website, and they've got this data set. The question is, how do we share this data? They could throw that data into a repository and then use either a data citation or a data availability statement to tie that journal article to that data set. Another option would be, once they have their data set in their journal article, to make that data set a supplemental file and also put that on the publisher's website so it sits neatly with the journal article all in one place. So to summarize, we have these two options. I've highlighted here just for fun the different bits of infrastructure we're working with here, right? We're working with the publisher's website, a data repository, data citation practices, and then for option 2, it's just one piece of infrastructure, really that website. Now, both of these options accomplish the same task, right? They share their data, but both of these options have different impacts. I apologize, this slide is very text heavy, but if we look at option 1, what this means is that if somebody has access to the data repository, they may have access to that data set. It's not put behind a firewall, it's not charged for, it's not on the website, which you might have to pay money in order to have a subscription to. It's readily available. If you go with option 2, it is not always true that a researcher will be able to access that data set if they are not part of an institution that subscribes to that publisher. So that this sort of seemingly innocuous decision about how to go about sharing their data has a real impact on inequitable or equitable access to information and data sets. And you might not realize that if you didn't center infrastructure at the beginning of your strategy building, right? So what the infrastructure strategy we set up has a real impact on equitable access to information. So our takeaways here is that both of these options perform the same task. They both share their data, but the infrastructure they use has ethical implications outside of that action. By thinking about infrastructure first, we're able to see some of these implications and develop strategies that sort of address these issues, including about how to communicate these issues to the larger community. Some additional points I want to mention is that it's always very important who owns a piece of infrastructure. Is this publicly owned? Is this owned by a company? This is sort of like a red flag to look for when addressing possible strategies for data sharing. And then finally, many of us make decisions about how to do something like share our data without knowledge of how this infrastructure works and what impact that might have. This isn't an individual flaw, but rather a question about how we surface this information and how we communicate this impact with each other. So this is something that we have to work together as a group to address. There is a quick question that I'm going to just answer now. In example 2, do publishers generally enable authors to share data on their site? That is usually done through supplemental files attached to a journal article. So if you look at a journal article, they might have data attached to that as an additional supplemental file. Publishers do generally allow researchers to do that with certain size limitations for those files. Now, moving on. I want to talk about how infrastructure works together in order to make some of these things like data finding happen. Excuse me while I take a sip of water. Now, most of my examples here are going to be about the data catalog. Again, that is a project I I run at NYU Health Sciences Library. But I'm also going to talk about schema.org. That's one of those metadata standards I was describing earlier. And Google Dataset Search, which is another data catalog, again, that I mentioned earlier. So um, the idea here is that we can make the most out of our existing infrastructure when we can understand how different pieces of infrastructure interact. And let's get into this use case to show you what I mean. So again, here's the NYU data catalog. Let's talk about how it works. So first, there's a researcher. Um, this is a basic science researcher. They speak to a data cataloger, which is at NYU Langone, is how we get data into the NYU data catalog. We have professional data catalogers. That data cataloger works with that researcher in order to get that data into the NYU data catalog with metadata that follows best practices in metadata creation, uses our metadata schema, and employs the correct ontologies for different keyword assignment and things of that nature. Now, from there, other scientists and researchers are able to access that data for reuse. And we went on like this for quite some time. Happily, it all worked well. This was our general workflow of how research got into the catalog and then reached other users. But then something happened. We had made the metadata in the catalog schema.org compliant when we built it. Schema.org, as I stated earlier, is a metadata standard that allows us to share information about metadata. It's a transfer standard. And so we had the NYU data catalogs metadata mapped to schema.org and designed in such a way that if somebody else was using schema.org, they could easily take a look at our metadata. And so it sat like this for quite some time. We had schema.org interoperability, but no one made use of it, and it sort of just sat on the back end as a thing that we had done. And then one day, Google Dataset Search shows up. They put this live. And what happened was I noted that our analytics sort of went through the roof. And we saw a tenfold increase in people coming to the NYU data catalog. And what had happened was Google decided to use schema.org interoperability to create a catalog that pulls any data set described using schema.org into their larger catalog, excuse me. So we really expanded our audience by leveraging this piece of infrastructure, this standard, and having it included on the back end of the NYU data catalog. So by implementing a oh, thank you whoever muted so quickly. That was well done. So by implementing a standard, we were able to expand our audience for the data catalog. And another takeaway here is that even when the current usefulness of a piece of infrastructure might not be clear, like when we did schema.org interoperability when we started, we really were able to leverage a community supported technology. And we were able to benefit from that community's expertise and technology projects that came later down the line. So something I like to think about when building a piece of infrastructure is, can we implement standards or other pieces of infrastructure in order to leverage that community's expertise? And then finally, this is just as a side note, when our audience expanded, we did have to make changes. So we had to change how we describe some of our data sets because we weren't talking just to the NYU community anymore. We were talking to the broader academic community. And so we did have to make some changes to our practices to accommodate this much larger audience. Now, when we are able to leverage pieces of infrastructure together for like an increase in audience like we did here, there are some impacts. And I want to talk about how efficiency functions when we make two pieces of infrastructure that can work well together, or in the previous example, three. We choose where we can create infrastructure efficiency in a piece of infrastructure. So we might make one task more efficient for a user, but we make it less efficient for a staff member or vice versa, right? We're choosing to make something efficient. Um, and when this happens, we might not realize that efficiency can serve a purpose or a role, even if we're not aware of it. So let me clarify what I mean. Let's go back to this diagram that shows the researcher talking to the cataloger, getting the data in the catalog, which then gets to other researchers and to other projects like Google Dataset Search. Now, a space of inefficiency here is this data cataloger. This is a person who has to do a lot of work. They can slow things down. It can take quite some time to actually create a dataset description. So this cataloger is sort of a source of inefficiency. And one thing we've been looking into at NYU are ways that we can try to address that inefficiency. And one of those ways is to see what sorts of AI assisted cataloging could be possible. Could we use something like ChatGPT to generate descriptions of data sets? And as we're investigating that, one thing I realized is that this inefficiency I stated earlier, this inefficiency of the cataloger, has accomplished things in the past. So in this example, a researcher tried to get data cataloged that included PHI. The cataloger, although occasionally inefficient, was able to catch that PHI and prevent this error from being spread both to the NYU data catalog and then also to Google Dataset Search. So if we're going to just think about those catalogers as inefficient, we're sort of missing part of the picture, right? Their inefficiency served a larger purpose, which was also quality control. Now, if we implement AI cataloging in a way that doesn't recognize this other role, then this inefficiency or this automation means that a possible PHI leak starts from the researcher and gets all the way through, gets all the way to Google Dataset Search, unless we're smart about it and recognizing that if we're going to automate the process of cataloging, we also need to consider the other roles a cataloger plays and automate around those tasks. All right. And before I get to takeaways here, I'm going to just answer another question, which I will answer live. The NYU data catalog was accessible outside of the NYU community prior to Google Dataset Search, but you would have to know to go to the NYU data catalog, which wasn't something people did outside of NYU. So Google Dataset Search really expanded our audience because all of a sudden other people were running into us who never did before. Um, and the second question, does NYU assign DOIs? I will get to that at the end if we have the time. And if not, you can email me that, but that'll take us down a rabbit hole. So the takeaways here when we're talking about efficiency is that creating efficiency may mean that one harm can become innumerable potential harms. What I mean there is, when the researcher accidentally shared PHI with the cataloger, one harm was committed. It was shared with this one cataloger. If that cataloger is replaced with some sort of AI automation, that one harm could have become innumerable amount of harms if that data was made available on the NYU data catalog and then on Google Dataset Search. So again, we have to be really careful about how we consider efficiency in these systems. The second is that when we are designing new pieces of infrastructure, it's really important to include all voices. I know that our catalogers have found pieces of PHI because they have told us. If I did not work to include their voices, I wouldn't know about these other roles that they play in our whole system. And it is also important to note that if you're not creating an efficiency in a system, you may even be causing harms yourself there. It's our obligation to help try to make data sharing more efficient. So we don't want to just shy away from it just wholesale. We want to do it intelligently, and we want to think about all the impacts efficiency itself might have. All right. So the second observation about infrastructure that I want to share with you all is this process of veiling and unveiling that I mentioned earlier. So infrastructure has this ability to make phenomena more or less visible. So by making something easier for our end users, we may be making complex operations and technologies appear less complex. To give a road-based analogy to demonstrate what I mean, a road will make your path more visible, right? You're like, oh, I'm taking 95. I know exactly where I'm going. But it can make other things less visible. So maybe the pitch of the road you're less likely to notice if you're driving in your car along I-95. But if you were walking in the woods, you would most certainly notice that you were walking uphill. To give a more detailed example, I'm going to go back to this diagram of the NYU data catalog and the interoperability schema.org with Google Dataset Search. Now, when we were talking about this, we were talking about the back end, sort of the experience of the catalogers and everybody who's making those pieces of infrastructure work. But I want to take a second to talk about how our users experience it. So our users might experience searching for data by just going to dataset, the Google dataset search, and then they find their data and then they're done. So they're not really considering all this stuff in the background. They're just getting their data from Google dataset search. They may not know, for example, each of these different sources that the data is coming from. Now, I found this surprising actually the first time I saw this with a user where they went through Google Dataset Search and didn't really understand the different sources that were feeding into Google Dataset Search, and that some of these sources may be more or less reputable. So through our previous conversation, we know a little bit about how the NYU data catalog functions. We know that there are catalogers that are working to describe that data and working with the researchers to make that happen. But we don't know if that's the case for all of these data set sources. So I just threw two up here. I threw up two that looked very reputable, but that's not always the case for data set sources in Google Dataset Search because all they need to do to be included in it is be interoperable with schema.org. But there are a lot of things that the researchers might not know here. They might not understand where these sources are coming from. They might not understand the difference in quality across these sources. They might not understand how schema.org actually functions and that there may be interoperability errors associated with schema.org. Sometimes the mappings with schema.org aren't accurate, and that can lead to issues with something like Google Dataset Search. So the point here is that in making some of our activities easier, by just making researchers feel like they're going to Google Dataset Search and then getting their data, infrastructure can veil, can hide some attributes of the dataset, like the initial source of the dataset. Now, one of the reasons I say veil here is because it is possible to find out where the original source of the data set is. They even include it in little text. It says source and tells you. But you might not notice that in the same way as if you're going to each individual source, doing a search on each separate repository, each separate data source. When assisting researchers with data sharing and cataloging, it's important to consider what parts of infrastructure may not be readily visible and what parts need to be considered in a data sharing strategy. This is something I struggle with a lot, actually, working with researchers. I'm very interested in infrastructure. I'm interested in understanding and knowing these things. The questions I always have to ask myself are, what does a researcher need to know about this? What attributes might they find ethically important or technically important? And how do I explain that to them in the half an hour I have to talk with them about data sharing strategies? And this final question is just a question I have for you all because it's a question I ask a lot to myself, which are what are the relevant attributes of a data set or a data set source that researchers should be informed about, and how might that information be presented? What is relevant to researchers, and what should we be surfacing? Something I've thought about in the past for Google Dataset Search is, wouldn't it be nice if they had another little metadata element that gives you some information about the data source, something that says, oh, this is curated. Oh, this is not curated. Oh, this is a government source. This is not a government source. Those attributes of each data source might be helpful for researchers as they use a piece of technology like that. We have an anonymous participant who has asked if I have experience with PIs at NYU with their data sets that they store them at several different sites for different purposes. And the answer is yes. Um, Most people seem to actually use different repositories for different types of data. Sometimes researchers have data that is, um, if not strictly confidential or protected, like it doesn't include PHI, it might be sensitive in such a way that they want to make some sort of application process. So if they have data about children or data about sexual practices, it might be allowed to be public, but they want to put it behind some sort of application process. So there's a lot of different attributes to data sets that'll impact how researchers decide which storage to use when sharing their data. All right. So now I want to talk about what this means for you. And what I hope you take away from some of these discussions of infrastructure broadly as a concept. Um, I'm going to go through this through three different personas. The first is a researcher sharing data. The second is a librarian or other person helping researchers share their data. And the third is a person building or maintaining infrastructure. Um, it's in my experience that a lot of people hold multiple of these roles. I hold all three of these roles, I think, in my job. Um, so, yeah, some of this may be applicable to all of you. Now, when you're sharing your data as a researcher, it's important to consider some of the following questions. First, who owns this piece of infrastructure and how might that impact longevity? How might that impact who has access? So this goes back to our initial example, right? If the publisher owns the website where the data is being shared, if it is held behind a subscription, um, that might mean not everybody can have access to it. It may also have impact on whether or not um, it will be there long term. If that publisher goes out of business, what happens to that data? Another set of questions is what kind of community support does the technology have? This is something I try to engage with researchers on about when we're talking about using maybe a specific data standard. How active is the community that supports that data standard? Do they have meetings? Are they openly available and transparent about their working processes? Making observations like that about the infrastructure we try to use will help us give an idea of, how long can we expect this piece of technology to be there? Is there somebody I can talk to if something goes wrong? Things like that. And then finally, does the technology interoperate with other pieces of infrastructure like standards? Are they leveraging the other communities that might be related to them? Are they able to make use of the expertise embodied in some of these other pieces of infrastructure or other pieces of technology? Um, I'm always really excited when I see a project that is very cognizant of other projects going on across the country or internationally, because I think it demonstrates a real interest in benefiting from the expertise of others in this field of open data and data sharing. If you're a librarian or other person helping researchers share their data, there are some questions to consider on top of the ones that researchers should consider. So this is sort of extra work for the librarians. The first is how can you best surface information about infrastructure that you're going to suggest using? This is really a thing I struggle with a lot. How do we best educate people about infrastructure? How do we make it clear the impacts that their infrastructure choices have on who their audience might be or the longevity of the availability of their research? And then another is, were there inefficiencies in the researcher's workflow that may have been serving an alternate purpose? So because I work in a medical center, one thing I do pay attention to a lot is if there is somebody looking at this data, are they actually checking for PHI and just not telling anybody? I've seen that a lot with project coordinators where, they are told to create a data dictionary and they do that, but they also do a check for PHI just because it's important to them to respect research subjects. So it's always important to keep an eye out for these types of inefficiencies and if we're accidentally getting rid of something really useful when we become more efficient. And then for those of you who are building or maintaining a piece of infrastructure, so if there's any, institutional repository librarians on the call, here are some questions for you to consider. How can you connect your infrastructure projects to other projects in order to leverage the expertise and labor of other groups? The NYU Health Sciences Library is never going to build Google dataset search, but by using schema.org, we were able to benefit from the work of the people at Google. Another question is, what information about your platform should you make readily available to the public? And is the use of plain language necessary to reach your desired audience? I am not a developer. I have never been a developer. And so a lot of times as I'm trying to find out pieces of information about a different infrastructure project, I have to ask our developer to sort of translate for me because I may not understand. So for those of us who build and maintain infrastructure, thinking about how to make documentation available in plain language can be really important to better serving your audience. And on that note, I have left about 15 minutes for questions. And I seem to have a few in here. Okay. We have one comment in the chat, but I think that's just a comment. And then we have, okay, where it's more questions about the DOIs. So the NYU data catalog does not assign DOIs to data sets because we do not store the data sets. Yeah, that's sort of the end of that question. Um, and then Sun Young asks if the same data set is shared across multiple repositories with different DOIs assigned, can the NYU data catalog or other data catalog spot this issue? We have spotted that issue before, and it's difficult actually to deal with that issue because it's hard to sort of suss out who you're supposed to call when there's multiple DOIs. But it does give us an opportunity to talk to the researcher about what a DOI is actually supposed to do, how you're only really supposed to have one per data set, and to basically work to get them set up to not repeat that error. So that's another one of those places where, having catalogers go in and take that time to look things through can really surface some of these issues for us. We have another anonymous participant. What is your major challenge at your library so far? I can't speak for the whole library. I can speak for myself and sort of the work I do there. And I think the most difficult thing really always comes down to communication, right? By the time researchers are sharing data, if they're not interested in sharing data as a topic, a lot of them are rushed. They're trying to close out a study, they're trying to get something published. And so we need to educate them quickly and clearly in order to, make sure they actually hear us while they're so stressed out. And I think day to day, that is the biggest challenge we face. And that's why, a lot of my questions center around communication, because I think that is the most challenging aspect of a lot of this. Sun Young, all right. Let's see. I think it's okay if you speak out loud. So go on ahead. What's your question?
Mute. Okay. I guess the host is not allowing.
We can hear you.
Okay, good. Thanks. It was a great talk. Thank you so much. So I want to go back to that same data set shared across multiple repositories.
Mhm.
I think it's happening more often than we anticipate. And sometimes they share partial data and throw in some other data and then get DOI. So we're going to have a lot of this redundancy. And
Yeah.
I don't know how we're going to address it. We do have an institutional repository, and I'm so looking forward to the NNLM, data set catalog. And I don't know how they're going to address that issue. So something we can discuss as a community, in the future as we develop this data catalog and everything. I want to hear your thoughts on that.
Yeah, happy to. So I think the NLM dataset catalog is much more automated than like the NYU data catalogs approaches, and it makes sense, right? They have such a wider group of people to be working with than we do at NYU. So I don't know how much of these things they'll catch. That would depend on their specific workflows, which I can't speak to. I think the problem of having multiple DOIs for a data set is further complicated by the observation you made, where sometimes they just add a little bit of data, right? So they'll be like, oh, here's my first data set. Oh, here's some more stuff. Let me get another DOI for this, instead of maybe versioning the first one. I think the real question at the heart of that is what constitutes one data set being different from the other. And I think it's actually a pretty complicated question. Um, at the end of the day, I would always focus my work on educating researchers on how to do better from here on out, because I think that looking at the backlog of data sets already shared is sort of outside what we are currently capable of doing with the amount of people we have working to address these issues. Okay, so we got a few more questions. Um, do we track usage metrics? Yes, and that's another example of a piece of infrastructure is the way we as metrics and practices around metrics. And data in the catalog, we don't track downloads, right? Because we just point people to where the data set lives. So we track things like how frequently do somebody click out based on those links. We do, which is a pretty rough proxy and not the best metric, right? So other things we do is send out surveys to everybody who's contributed to the data catalog to try to get a better idea of, real significant use as opposed to just those clicks. That is an infrastructure project I would love to leverage if somebody else worked on managing metrics for things like that. How do you go about teaching researchers about data infrastructure? Man, I am trying to figure that out every day. A lot of times I try to keep it very specific to their work. It's like, okay, here are the repositories that relate to, public health related things and try to keep it very specific because they might not care about all of these other things that don't relate specifically to their research. But I do try to talk about standards and interoperability, even if it's just a few sentences, because I think understanding interoperability really puts you in a position to make the most of your infrastructure choices. Because if you have a choice between a repository that is schema.org compliant and isn't schema.org compliant, that interoperability might be the thing that actually makes that choice for you. What are your institution's policies regarding sharing data which originally contained PHI? For instance, does a certain group or office take responsibility for de-identification? No, generally speaking, it's the PHI's response, the PI, excuse me, responsibility to ensure that PHI does not go out. We do have technologies put in place on, campus firewall so that if large data set or if large files are leaving, they are checked for PHI. So there's different technical approaches meant to guard against that, but there's no singular office in charge of it. Yeah. We do have a data sharing strategy board that does review requests to share data that was generated from clinical practice. And there's different groups like that. But these groups are really dispersed across the institution. Some of them are academic, some of them are IT, some are legal. So it's not very centralized. And then Josh asks, okay, I'm going to just read this out loud, excuse me. Is that in the long run a helpful way to think about people's workflows and processes? Might another way to approach it be that as librarians and data stewards to develop insights into the messy work that people do or don't do within scientific enterprises and characterize its complexity rather than a binary efficient and inefficient? Interested in your thoughts and reactions, Josh? I think that's a great observation, right? I put it this way. as efficiencies versus inefficiencies, because I think sometimes we have this push to be as efficient as possible. We want to, be as productive as possible so that when we present whatever graph to our CEOs, they can look at us and be like, oh, you've done so much work in such a small period of time. So that was sort of why I went for this binary, because I feel like sometimes that's put upon us when we're trying to answer those metrics and provide those reports. But I think the way you talk about it, where a lot of our work is complex, and we need to think about that complexity, is a much more academic approach, and I think it's very, very accurate. And yeah, if you have more questions, Josh, feel free to ask. I'd love to talk about things like that. Excuse me for my delay. I've not used a Q&A thing on Zoom before. This is very fun and exciting. For the DOI topic, have you seen some researchers trying to inflate their research outputs as citation inflations? I have not. I know our institution does not really consider shared data as a part of their tenure process. I think maybe if they did, maybe we would see that. But I think now we're still really not rewarding data sharing in the way that we maybe should. So there's not really incentive to try to game that system. I'm not saying it doesn't happen anywhere. I'm just saying I haven't seen it happen here. Okay, and I'm just checking the chat, excuse me. All right, that's just more discussion about relationships between data sets and schema.org. Tom, I don't know when the video of this training will be posted on YouTube, but I think Peace may be able to answer that. I think they get up pretty quickly within a few weeks.
Yes, I can answer that. The slides and the recording will be shared once they're processed by the end of this week. I've shared the evaluation link also in the chat. If you need me to, I can reshare it. That information will allow you also to obtain MLA continuing education credit. But even if you're not interested in MLA credit, we would really appreciate if you fill out our speaker evaluation. It helps us understand which presentations and offerings that we provide are most useful and better able to create offerings that are useful to you in the future. So without any more discussion, we are just a few minutes early, which is great and gives you time to complete that evaluation and obtain your CE credit. Thank you so much for attending. We have one more webinar, which is tomorrow, which is about gray repositories. I would encourage you to attend that as well. And otherwise, have a great day. Thank you.